Hello. So in the previous video, I showed you how to scrap Wikipedia and get the links from Wikipedia. And just a recap, if we go to Wikipedia now, let's say we want to look at data science. What will Wikipedia tell us about data science? So you get information here about data science. And in the previous two video, I showed you how to use Python so that we can get these links from a page, and then we used a recursive function so that we can scrap close to all links in Wikipedia. I made some changes in this code, and I thought that I could show you before I continue with analysis of the data that I got from Wikipedia. The data took so long to run, so this, I can call it an algorithm, took so long to run, so I had to have some hack for it here, so that I could download it. So that I could scrap the links from Wikipedia. So let us just go through this code so that you get to understand what happened, and the changes that I made from the previous code so that I could get the data that I wanted from Wikipedia. So we are using Beautiful Soup as a package to scrap data from HTML files. We use requests to send a GET request from Wikipedia, and then pandas is for data manipulation, data wrangling, and I usually say that pandas is like Excel for Python. And then we have NumPy. This is NumberPython, will help you to manipulate numbers in Python. And then there is a time, I use time. There's so many usage for time. Anything you need to do with time, you can use time. But for this case, I used it to sleep, to pause the run of of our algorithm. You will understand it as we go on. So Wikiscrape was the class that we created previously. If you have not looked at the previous videos, I would advise that you look at them so that you see how we developed this class. It has a constructor which has all links as the only variable, and it is a list that we create. And then so in the previous video we didn't have this part, so this part here is to help us stop. If I was to leave this code to run, it would never stop because there are so many links in Wikipedia and it would take a lot of time. So I put this stopping condition where I say if the length of items, if the number of items in links is 10,000, then it should stop, it should return none. Or if the sorry about that, or if the number of steps, remember this we were looking as steps from one page to another, like if this was step 1, then we click here and we go to the next page, that will be step 2, then we click here, we go to the next page, that will be step 3, then we click here. So if we move 8 steps, we could also stop, and then we save that data. So this is the get request, the request that gets the HTML page from the server of Wikipedia, and then from there we get the content, and it will be HTML content. Then we convert it into a format of Beautiful Soup that we could be able to get these other tags and the content of the HTML file that we get. So all this we went through it last time. Then I made some changes here. So here was now trying to find which kind of links we should include in our list of links and which one we should exclude. So here I added this. I'll make sure that the link does not have a file name extension as .svg, as jpg, jpeg, and png, and it also does not have shortcut in it. So when I was running this class, when I was calling this class, it would take long, and then it would break when we would reach on these links that have jpg at the end. So I had to exclude them. So this part here on the condition of if was just to exclude the links that have this. Then this, we remember what we did here, this is fine. And then the steps, then this was now the next iteration, or we call our function, because it is a recursive function. So this is the next recurse. So from here, our class is complete, the wiki scrape, and we create an object here called wiki scrape, and we started this as our link, and then testing it with because it takes in the number of the number of steps. This was me calling it for the first time, and I put their steps as 1, and then so that it could. So here it starts with steps equals to 1, and then we continue adding steps up to when the steps is 8. Then it exits the loop here, and it exits the run of this function while returning none. But as it returns none, all our links are here, so we could call them and then create a data frame from them. So when it ends, basing on any stopping condition, it would end after something like less than 5 minutes. So it was easy for me to wait, and then it ends, and then from there I converted the links into a data frame df, and then renamed the columns of the data frame, and then I removed the duplicates because there are some links that would duplicate from source to destination. Then I save it as a CSV file. But this one would happen up to when it stops. That means that we have not grabbed all the links from Wikipedia. So what I did was to create a loop here for I in range 1000. Then I have a checkpoint data frame, is the data frame that we saved here. Remember, data frame to CSV. Then I I import this data frame. So then I imported this data frame here, and I call it a checkpoint data frame. Then I picked the last link that we picked, so a destination link. Yeah, so I was saying that when we get the checkpoint data frame, we get the last value that is entered in the checkpoint data frame, the tails, but we get a random value, the random number of values from there. Then we get the first one from it. So it will give us, for example, if this random int gives us 49, then we get tail 49. That means that the last 49 values in the data frame. Then we get the destination. That means that we're going to have 49 links. Then we pick the first one, so that will be the 49th the 49th value. Then we create a new object with wiki scrape. Then we give it that URL that we have picked randomly, then the first one. Then from there we do what we did here. We run it. It will run, and you will have the same stopping condition as this condition that is created in the class, and then it will return the data frame here, the links. So we created the data frame here, so we create the data frame here, and this is the data frame returned, and we rename the columns. Then we concatenate the two data frames, the original data frame, this one here, and the data frame that we got in the iteration here. Excuse me. Then from there we drop the duplicates, and then we save it to CSV, and then we run another loop. So I put it to 10,000. I didn't complete it to 10,000. It was throwing some errors after some time, which I think the errors may be coming from here. I haven't debugged, but I got enough data that I think would be enough for the analysis that I'm looking for. And print checkpoint. This is for me my visual aid to see where I am in terms of the number of records in the data frame that I've created, and then the loop. Yeah, so at some point it would stop, and the length of the data frame would be the same. That is checkpoint df and this df. That means that you have this checkpoint df. Whatever you did here created just duplicates which were dropped here. That means that you have now the same data frame here as here. And if it is so, I would randomize again from 10 to 1,000 and get the destination, and I try again. If it happens twice, I would leave. So, and that is the point where I left, and I got this data here which has source and destination, and it has data which we are going to see how many records. Can I see from here? It has this is 164,470 records, which look much, but when you do unique of this, I think there will be few. So there is where I stopped, and I want to do analysis of this data. I know you may be wondering which kind of analysis, and we are going to work with the networks. So if you do a search on the same site that we are working on, and you say graph theory, my typing, theory, and we look at this. So it's a mathematical discipline. Graph theory is the study of graphs, which is a mathematical structure, and this is an example of a graph. So you have nodes. A node is a unit. For example, let's say you're looking at network of road, and then node will be like junctions, or a place where two roads connect to. Then these lines here are edges, and the edge may be the roads themselves. You may be looking at a network of computers, for example the internet, where the node is a computer, and then the connection between the two computers is the edge. And in this case, for us, the network is comprised of the pages, and then the links are the edges. So this may be page 6, and then the link from page 6 to page 4 is here as the edge. Then this is page 4, and it has 3 links, which moves to page 6, to page 5, to page 3, and so forth. So we are going to do some bit of graph theory. There are people who call it complex networks. I'm sorry, complex networks. So complex networks is an expansion of graph theory, but it looks at networks that have so many nodes that you cannot easily comprehend by just looking at them. For example, a social network, like a network of Facebook or LinkedIn, where a node is an individual, and then a connection is when you're following someone or your friends. Those networks are so big because you have billions of people on Facebook, and it is not easy to understand them by just some simple mathematical formulas of graph theory. You need to do more using the domain of complex networks. But for now, we are going to use a package. I think it's called NetworkX. I installed it before the video, and so presumably I think we're going to use pandas and as speedy. Then I'm going to use NetworkX, put NetworkX as So majorly pandas is as PD, NetworkX is as NX. You can read more about NetworkX in the documentation. I'm going to plot something, so import matplotlib .pyplot as plt. Then let me just set the size here for matplotlib. Import matplotlib, import, yeah, matplotlib. You just copy this. I'm lazy. All programmers are lazy. I'm going to do from this. I don't want to import everything. Import figure. And then plt dot. I want to change some parameters of pyplot. It is params, I think, and then I want to change the figure size. We will come back here later. Figure dot fig size, and I want it to. This is not a function; it is parameters. I'm sorry. Okay. And I want this to be. I'm usually using 20 by 20. Just a nice square figure. Yeah, so I think this is what I need. Then let me import this data. So my data is going to be pd.read csv, and I am reading this file here. So it is wiki.csv. So data.shape, let's see what's there. I think you've already seen what I showed you. 164,470, and then 2 columns. And if you want to have a sneak peek of how that data looks like, we do a data.head, and this is how it looks like. Okay, so what should we do with this? Still thinking. So first of all, if I look at these ones look like, so this is already a duplicate anyway. So let me first look at this. I don't know why this happened. I just want to confirm that this part of the link is the title. Let me try with another one. Let me try with tail. Let's see if I have tail 1 dot values. Yeah, this is project Norway, Wikipedia colon project Norway. So we can try to extract this from the links. So I'm going to say extracting titles from the links. I don't know if my keyboard is making noise, but hopefully. So how will I do this? Let me see data, then source title. Source title, we're going to have data, and then we pick source. Then we say we are going to apply for each of the rows lambda. So lambda is a pseudo function. Then I want to this link here. So I should split it by backslash x.split by backslash. I have to make sure that this is a string, just ensuring that I'm working with a string. So that is I've splitted it by that. Then I pick the last value. So you know that in a list, for example, if you have a list 1 2 3 4 and I want the last value, that will return 4. Yeah, so I wanted the last value, which will return this Norway, and then from there I want to remove this. I want to remove this underscore, so I'm going to replace the underscore with the space. I'm still rethinking, do I need to keep the Wikipedia with a colon? No, I don't. So I'm going to here replace, and I'm going to replace so that I can remove the colon, that colon with that. So all colons will turn into backslash, then we split by backslash and pick the last one. It should give us that. So this code is getting lost from somewhere. Let me just split it from there. Okay, so we are going to do the same for destination. So let me call this destination title, and it is the same thing. Then I run. Cool. So how is our data looking like now? Yeah, so we have this. I kind of think that we don't need the source and the destination now, but let me just keep them. Okay, so instead of working with the data, I'm going to work with a data frame that does not have the source and the destination, because I doubt if they are useful. So let me remove destination, remove those columns. Axis equals to 1. So we can look at our data frame now. It will look like that. Yeah, and I'm saying that this is not going to give us, it's going to give us a loop. I think when we print the network, you're going to see that that will give us loops. Yeah, the question that I may ask myself is, how many unique values do I have here, and how many unique values do I have here? So I can do data frame source dot unique. What's the error here? Oh, but it's supposed to be source title. So it gives us array, but distinct array of the source title. Oh, this is desert, this is desert. Okay, cool. Then what is the length of this? They have length in that. Yeah, so we have 541 unique values for source title, and then we can try to look at the destination title, and there are a lot, 87,000. Yeah, so I think we are going to only use links in the destination that exist in links in the source, because this graph is going to be big and it's going to take us a lot of time to plot it. Remember, what we are trying to do is just some bit of analysis of the links and how they are connected, and see if maybe we can cluster them or group them together basing on how they are related. Yeah, so let's hopefully we can be able to accomplish that today. Yeah, so I want to do that now. Yeah, I should do that. I should define, I should create a column called keep. I am very I'm very creative with the names of columns. So destination title, and then I'm going to work on each value. So we're going to do the same. I kind of like apply lambda x. So we're going to say it is true if x is in, do I need to do, I think df dot destination, no, I want to create unique values of destination. So destination title dot unique, true if x is in that, else is false, else we say it's false. I'm going to break this code from here, but it means that for each x we're going to do this computation. So this is not going to be right. So I'm going to do, I'm just going to call it sources. Sources. No, this should be source. What am I doing? Not source, it should be source title. Source title. So sources is going to be a list of this. And then we're going to put sources there. Then I think this code is now shorter. Yeah, so what we are trying to create is, this is a boolean field with true or false, and we're going to say if the title is in the sources, then it should be true, else if it is not in the sources, then it should be false. So I'm going to run this, then I run this. Yeah, so data frame dot head, you can see true, 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 true. But now I want to remain with only data frame. My new data frame should be data frame where the sources exist. So keep equals to true. So this will give me a data frame which has only truth values, and then I'm going to drop that keep. I don't need it anymore. I created that column just for this purpose. Axis equals to 1. Then what will be now my data frame? That is how it looks. And how many records? Shape. Yeah, so it has 6,900. We have moved from hundreds of thousands to less than 10,000. That's fine. Also, so this, when you do data frames of shape, gives you the number of rows and the number of columns. You could just, trying to get the number of rows, you could just do the length of the data frame and it will give you still the number of rows. That's just another way of doing it. So now that we have a lighter data frame, I would like to yeah, so what should I do with this? For fun, I'm going to, yeah, you could create a network from this, but I prefer nodes numbered than having words on nodes, because if you have a network plotted and it has words, then it looks kind of cluttered and it will look cleaner if it is numbered. So I'm going to just to play with the sklearn, from sklearn import preprocessing. Is this spelling really? Does it? Yeah. Yeah. So then my what I want to do is to encode this. So it's a number encoding. I don't know if you're familiar with number encoding. You could read about number encoding and one-hot encoding, or I could make a video in the future. If you want a video about encoding in the future, you can tell me in the comments below. But I'm going to do number encoding, where each instance of this title, I can't pronounce this, is it all of desert, will be given a particular number. So if all of desert is 0, then this will be 0 0 0 0, then this will be 0 if they're the same. No, they're not. This is desert. This will be 1, for example, then this will be 2, but if this exists somewhere else, it will be 0 1, which is fine. So that's what I'm going to do here using a function in sklearn. So I'm going to do source encoding is going to be preprocessing, not property, preprocessing dot label encoder, then I'm going to say se.fit, and I'm going to fit my data frame, and this is a source encoder, so I'm going to do source title. Then from there, after fitting, I don't know if label encoder has fit transform, but let me just fit, then I transform. So my data frame, the new column is going to be, let me call it source label. Yeah, the spelling of label. Yeah. Label will be my source encoder dot transform. I think transform my data frame source title. Yeah, let me see if this works. Yeah, this is fine. So let's do the same for destination. So here I'm going to have destination encoder. Here. Okay, then this is destination. Then here, then here. Okay, this is fine. I run it, then let's try to look at how our data frame looks like. Okay, so you see desert of all of desert is 159, so they're all like 159 159. This is 158, this is 160. We could try to look at the tail, data frame dot tail. So you see this one here, wiki project Norway, is 509. Yeah, so this is fine. So I want to create a graph now, so I can call it the network data frame, because I don't need the source and the destination, so it will be that dot drop source title, source title, destination title, x is equals to 1. Okay, then from there we can use NetworkX to create the graph from records, from tuples. So what we're going to do here is I'm going to create records of the data frame, and it's going to be a list, and this list is going to be the list of records from the data frame without index. So it's going to be n underscore data frame to records, and it's going to be index should be false without index. Then I want these records should be, I'm going to do a list comprehension here. I don't want the record to have something like this: wiki project Norway, wiki project Norway. I want to remove this because this is a node that is pointing to itself. I don't want that kind of a loop. So I in records, if I not the first value is not equal to I1, sorry, I1, I for I in. So they're saying that I is not, this should be if. Okay, so this is what I mean by records. They're just list of tuples. So 158, 159, 158, the way you see here, 159, 158, 159, 160. So these are now edges that we have created. Now we're going to just call our graph. So the object, we like saying G NetworkX dot graph. Yep, that's our G. Then G or graph dot add edges from records. Records. Yeah, so it's easy, it's fast because we don't have so many nodes. We have removed lots of them. We could try to look at the number of edges, the number of nodes. If you wanted to calculate, like we could say G dot number of nodes. Sorry, it should be a function. We have 541 nodes. They have drastically reduced from hundreds of thousands. Number of edges, 4,800 edges. And then you may want to look at how this graph looks like. So it's going to be NetworkX dot draw, and what we are drawing here is G, the object. So if your graph is so huge, this will take a lot of time to draw, but our graph is not so huge. So if you look at this graph, it's just a connection of Wikipedia pages. I'm trying to reduce the size so it can fit in the screen, and you can look at the whole network from here. So from what I can see here, I can see that we already have clusters now. Like this is a cluster, and these are pages that point to each other. So that means that this may be related content of the pages, and if you are a content creator for Wikipedia, this will be good for you, because if you select this link and this link and this link, you could be Wikipedia could suggest for you this one and see how your content is related to this one, and maybe gives you more insights. And I know inside here in this bush there are several of these clusters which we could try to identify. Let me try to, I don't know if this is clear. Let me just look at my recording here. Want to increase this to a size that is the code is clear for you. Okay, cool. Then we are going to reduce this maybe to 10 by 10 maybe, or 5 by 5. So this is what I was saying, this is the size of the chart that we have drawn. So if I run this, and then I come down here and I run this again, it's now like a blob. It's not looking as beautiful as it was when it was 20 by 20, maybe 10 by 10. So it's now like a hack to see how best you visualize the graph. But some graphs are so complex that this is the other cluster that we're talking about, that you may not be able to see clearly the way we saw when we were at 20 by 20. So it's better we just remain at 20 by 20. Yeah, then I run this. Yeah, this is kind of clearer. Yeah, so we can, this is kind of clear, but we can maybe I really like looking at, not with the links, I want to add in here, draw that with the underscore. It's supposed to be with labels equals to true, I'm not sure. Yeah, so if we left our network with these names, this will be so cluttered, it will not be easy to read. But you could easily see this is node label, so 11, 5, this fall in the same group, then these other ones, then you can translate it and see, okay, 509 means this, and then this title is related to this link, for example. Yeah, so but how can we, since we can't see clusters here, how can we like use machine learning to cluster this network? And that is what we are going to do here next. The package that we're going to use first of all is to generate walks. So a walk is like moving from one node to another. I can walk from here 11, I go to 9, I go to 226, I go to 79, I go to this 79 is connected to 374, I go like this. So those are walks. So I need to generate walks, and the package that I can use for generating walks is going to be node to vect. It's like vectorizing, you know, like word to vec. So this is node to vec, we're vectorizing it to get numbers. So from node to vec, import node to vec. Then I'm going to generate walks. So node to vec, very creative again. And node to vec, node to vec. Then I'm going to give it the graph. Then I want it to have 2 dimensions, that means like 2 columns. So like a vector that has 2 values. Remember a vector, if you Google what a vector is, Wikipedia again, because we are working with Wikipedia, I don't want that. We are working with Wikipedia. So a vector, vector. I don't want this vector, math, yeah. Okay, a vector is something with direction, but it is majorly represented in column form. I just want the representation. I can't seem to find a representation of a vector. Yeah, vector is a direction, and then it has the weight and the direction of something, or the value and the direction of something. Yeah, let me just look at image. I see where there is just a simple illustration of a vector as numbers, so that I can justify why I'm putting 2 like this. Yeah, so this is a vector. It has 2 and 1 like that. You can have a vector that has so many values. It depends on the space that you're working in. So here I'm going to say the dimension. Yeah, the dimensions is going to be 2, and then how long do I want it to walk? This one, the walk length. I don't know how long. We could start from somewhere and see if maybe the topic change, how long it will take for us to move until the topic changes. So let's say data science Wikipedia. So Wikipedia data science, let me see. So 1 2 3 4 5 6 7. So we have gone 7 8, let's say around 10. If you move like 10 steps, yeah, I think the topic may have changed. Then how many numbers of walks do I want? Let me also get like the number of walks should be like 5. I'm working on CPU, so let me just define the number of workers as 4, so that it does not overload my computer. Yeah, so that is my node to vec. So my model, let me define my model to be node to vec. I don't know why I called it this long one. Node to vec dot fit. I'm going to fit in a window of 10, and then the minimum count should be 1. So it will be learning the embeddings of our model. Then I want to save our model somewhere, so I'm going to say model dot wv dot save want to vec format. So it should be an embedded format, so just going to call it embedding dot emb. What's happening here? Node to vec is not defined. Which one? From then this. So this is not defined. This uppercase should be excuse me. Yep, it's working and it's done. So it is saved, and we can now use kmeans to cluster it. So from sklearn dot cluster import kmeans, then from I'm going to use numpy. I already imported numpy up here. I'm just going to confirm. Nope, why didn't I thought I imported it in the other side. Okay, cool. So import numpy as np, import numpy as np, So my x is going to be np dot load text, and what I'm going to load is what we saved. Sorry. So I'm going to load this, and I'm going to skip the first row. So skip rows equals to 1. So I'm skipping the first row because the first row does not have all the columns. So if you have a sneak peek of what x is just this. So the first value here, so let me just explain. So this, the whole of this is what we have generated here, the dimensions and the vectorizing of a node. So it is vectorized with 2 values, but you're seeing here that the output is having 3 values, because this one here is the label of the node, then this is the vector, the values of the that is generated. We could say the dimension is 3, 4, 5, it depends. If I did, sorry, if I did let's say 5, then you're going to see 6. Yeah, so you're going to see 1, 2, 3, 4, 5, 6, where this is the name of the node, but I don't want to do that. I want to do 2. We start from 2 and that's how our x is looking like. I also want to sort it. I don't know if it is necessary. I don't need to sort it, but if I doubt if I need to. I just want to remove the node index, so let me just say z, let me leave x as x, get the first column to the last column, that is x dot shape. Okay, I mean the first row to the last row, shape 0. Then I want to get from the second column to the last column, x dot shape, shape 1. So what does this mean? Get all rows, all the values of the rows. So I'm going to get this, I get this, I get this, all rows. But when it comes to column, don't get the 0th column, get the first and up to the last. So from this up to the last, this is index 1, that's why it's 1, this is 0. Yeah, so this is going to be my z. Run this. Just want to run them each one by one. Then I'm going to do my kmeans. Kmeans is going to, let's instantiate kmeans. Number of clusters. For now, the number of nodes have reduced to a few, so let's work with 5 clusters. And to be able to replicate this, I'm just going to say random state equals to 0, and then I'm going to do dot fit z, and we have our kmeans. So what are the labels? So we do kmeans, this kind of typing, kmeans dot labels. Yep. And so this is the 4th cluster, this is the 3rd cluster, and all these are matched to how x looks like. I think I'm kind of done, but let's just try to make it more practical. So for example, if you did this to Wikipedia and you want to give results to maybe your manager and say, okay, we have these links and this is how they are clustered, and then maybe your manager is going to give this to people who are developing, so that suggestions will be happening to people who are writing content. So let me just create a data frame. Result is going to be mypanda dot data frame of x. Then I'm going to say, if you look at result dot head, looks like that 0, 1, 2. So remember, this was the label of the column, and then this was the vectorization. So I'm going now to add the label. So result, the third column label third should be kmeans dot labels. Yeah, so yeah, so let me look at results. Result, I mean, dot head. I like looking at what I'm working on. Yeah, so this is the label of the node, and this is the cluster of the node. So I could do result dot columns will be equal to I'm just going to call it source label, because the source and the destination, at least they exist together. So source label, and then just going to give it a random figure, a random name, A, B, and then the other one is a cluster. So I'm just looking at this. This is that, this is A, this is B, and that. So by now we don't need this. We need editing clustering. So we have this. Then I'm going to remove. So result equal to result dot drop. I'm going to drop A and B. Axis equals to 1, and then we can do result dot head and voila. So what's remaining now is for us to merge the data frame, and then I think we will be done. But before then, I don't like these decimals. I'm going to remove these decimals. So can I do source label, source label dot apply the x integer of x. Okay, so this should be equal to that. What is result dot head, voila, just remove that. Then I'm going to try to merge them. pd dot merge yeah, pd dot merge df and result on, so the column is source label, label is A, and I want it to be left join, so how left, voila. And you can continue merging with the source title to get the links, but you can see this belongs to cluster 0, then this belongs to cluster 1, and I think yeah, so this has been a good project. You're going to find the link to the code in the description. Yeah, and have fun, do more with it. I think this is where I'm going to stop with Wikipedia before Wikipedia comes for my neck for overwhelming their site. But I think with the previous hack, this hack here, it was easy not to overwhelm their site, because at some point I would sleep for like 60 seconds. Yeah, so that's about scrapping and analyzing data from Wikipedia, more so their links. If you like this, please subscribe and have a nice time.